Hello everyone, my name is Lakshman and I am pursuing a degree in the CS department of the SVC Engineering College located in Bangalore. And today I am here to explain about the pointer aliasing concept in the subject of microcontrollers and embedded systems. Microcontrollers are the small chips that are optimized to control the electronic devices, and embedded systems. Introduction. What are embedded systems? Generally, embedded systems are defined as the combination of hardware and software of a system. As we can see in the picture on the left side, this is the picture of an motherboard, which is also known as the brain of the computer, and it is located in the CPU. And as you can see in this picture, there are many components like the CPU, transistors, memory controllers, and others. And the examples for the embedded systems. Embedded systems are used in automobile internal features. Automobile internal features are like adaptive cruise control and backup camera, airbag, and the next example is the mobile phone operating systems. Nowadays, the technology is so developed that various operating systems are used in various mobile phones. Some of the examples for the mobile phones operating systems are Qualcomm Snapdragon, MediaTek, and others. And the next example is the medical scanners and equipments. Nowadays, the medical field is so developed that the health condition of a human body can be recognized by the various machines used in the medical field. These are some of the applications of the embedded systems in various fields. The first one is the gaming machine. The next one is the electronic books and tablets that we use in our daily life. And the next one is television. This is the most common appliance in every house. Industry, airlines, and space. And the next one is broadcasting and medical. As I have mentioned before, it is used in the various medical fields, in the various machines. Digital signage, amusement machines, printer, and car features, mobile phones, and smartphones. Now let us go into the main concept of pointer aliasing. As we can see in the heading, there are two words in the concept, pointers and aliasing. Pointers are the user-defined data structures that store the memory address of other variables as its value, and it is denoted by star p. Example, in this program, int star pc and c, comma c are the variables that are used in this program, and c is equal to 5 is the value that is assigned to the variable c. pc is the pointer variable that stores the address of c, and symbol represents the address variable. Here, 5 is assigned to the variable c and the address of c is assigned to the pointer pc. The next, aliasing in computing describes a situation in which data location memory can be processed through different symbolic names in the program. For example, these are some of the instructions that we used in the microcontroller programming. ADD is for the addition, ADD is for the addition, and SUB is for subtraction, MUL is for the multiplication, and DIV is for division. In the next slide, we come across the explanation of the previous slide program. If the address of the variable is taken, the compiler must assume that the variable can be changed by any assignment through a pointer or by any function call, making it impossible to put into a register. This is also true for global variables as they might have their address taken in some other function. This problem is known as pointer aliasing because the pointer is known as an alias of the variable it points to. Example, the following function increments two timer values by a step amount, and void timers is the function used. Int star t1, int star t2, int star step are the variables used in this program example. Star t1 is the pointer, plus is equal to star step. This this instruction means that t1 is equal to t1 plus star step, and t2 star t2 plus is equal to star step. In the next slide, we come across the explanation of the previous slide example program. as we have seen this as we have seen this program in the previous slide, and these are the basic instructions that are used in the microcontroller programming. As we can see in the first instruction, LDR is an instruction that is used to add 32-bit value into a register, and R3 is the register number, and R square bracket R0 refers to the address of the register R0. Add is the instruction used for the addition of the registers and value. As we can see, add R3, R3, R12. This instruction means that the contents of R3 and R12 are added and stored again in R3. STR stands for string R3, square R0. In the next instruction, LDR R0, square bracket R1. Next instruction, LDR R2, square bracket R2. LDR R2, it stores the address of the register R2, and it adds the 2-bit value to the address. In the last instruction, as we can see, MOV is an instruction used to move the contents of the register into another register. As we can see in this instruction, move PCR14, the contents of register R14 is moved into the PC. This is the pointer variable that we have seen in the previous slide. In the next slide, we come across the basic instructions explanation. Here we would expect that star step to be pulled from memory once and used twice. That doesn't happen because one rewritten to cache star step is in a local variable. The redundant load is eliminated. The same problem arises if we use structure accesses instead of direct pointer access. Let us see some more important points about the pointer aliasing concept. If a function has two pointers pa and pb with the same value, we say that pointers alias each other because one pointer stores the same value as the another pointer. This introduces constraints on the order of instruction execution. C99 introduces the restrict keyword that specifies that a particular pointer argument does not alias any other. If you know that pointers do not overlap, using this keyword to give the compiler this information can yield significant improvements. As we can see in the right side, this is one of the examples that I've used for the important points: void foo, unsigned int pointer 1, unsigned int pointer 2, and unsigned int pointer I. Star pointer 1 plus is equal to pointer I. Pointer star pointer 2 plus is equal to star I. In this example, it must read the value star I from the memory twice, once for each add, as it cannot be certain that changing the value of star pointer 1 does not change the value of star I. If the function is instead declared as void foo unsigned int star restrict pointer 1 and unsigned int star restrict pointer 2, unsigned int star restrict I. The difference between this code and the previous code is that after the unsigned int, the word restrict is used to change the differences between the programs. This means that the compiler can assume that the tree pointers might not refer to the same location, optimized accordingly. In the next slide, we come across some of the disadvantages of the pointer aliasing. Do not rely on the compiler to eliminate common sub-expressions involving memory access. Instead, create new local variables to hold the expression. This ensures the expression is evaluated only once. And the next point is avoid taking the address of local variables. The variable may be inefficient to access from then on. From the last point, we come across that each pointer should have its own specific address, and more than one pointer address cannot be stored in another pointer. So that's the end of my presentation, guys. Thank you for all, and hope you guys like the presentation. And please do like, share, and subscribe my YouTube videos. Thank you.